Your notebook and your journal should be inside your desk, and your iPad. What Okay, guys, we're gonna start off the lesson with a building activity, practicing our benchmarks. So I'm gonna pass out your papers. I'm gonna give y'all some time to work on this. Be sure to put your name at the top of your paper. It's just one side of it. Because I thought this would be with that, so I thought that would be something to do. Because I thought it would be good for like the building, or since it's the lessons, benchmarks. Is that okay? I'm gonna give y'all a little bit of time to work on this. At least, I want y'all to read the directions and get through 1 through 10 at least, okay? Get through 1 through 10. That's the main ones I want y'all to be sure that you get to, is 1 through 10. Read the directions. Okay, and I'll kind of read them as y'all are getting started on the first section. They want you to shade the figures below to show the fractions that are represented to the left, the actual numerical portion of the fraction. Then write less than, greater than, or equal to on the blank lines after you compare the fractions, okay? Does everybody understand that? When you shade it to show what the representation of that fraction, and then once you do that, then you do the comparison to see which is greater, less than, or equal to. And then on 3 through 6, on the line beside it, you're gonna write whether each fraction is closest to 0, half, or 1 whole, okay? And then on 7 through 10, you're gonna circle the correct fraction that answers the questions that are given, okay? Be sure that you write your name on there. We'll give y'all about 7 minutes. Has everybody got the first 10 done already?
Yes, ma'am.
Everybody? Okay, well then, I'll give y'all a couple more minutes, that way we can move on to the next part of the lesson. Yes. Okay. On each line, you have the right fractions closest to this, is it, you can draw one median on the piece of paper you want to show which like, even how you do it, start with 0, and then go to y, and then this is 1, 6, 7, 3, so how many pieces is it gonna be? Divided into. Okay, so draw your, you might wanna draw your number line, and then you see which number is it closest to, is it closest, when you do your number line, is it closest to 0, half, or, half is right in it, right in the middle. So get you a piece of paper and you can draw your number line. So you can divide it into pieces, it's representing fractions. If y'all got to 10, then you can get to, then you can stop. Are you done again? Which one's closest to 0? But I just gave you yours. Okay, we want to start finishing up so we can move to the next part. If everybody go ahead and stand up behind your desk. Okay, I'll come get it. And put it in your basket and I'll come get it in just a minute. Just stand behind your desk so we can do our fluency practice. Same thing, Kelvin. Stand up, push your chair in and stand behind your desk. Push your chair in. Don't mind, push your chair in and stand behind your chair. Say again. Push your chair in and stand behind your chair. Just do like y'all normally do. Push your chair in, stand behind your chair, and we're gonna do fluency practice together, okay? So we're gonna count by twos. We're gonna count by twos to the number 16, starting with 0. So as I write them, I want you all saying them aloud, okay? So 0, 2, 4, 6, 8, 10, 12, 14, 16. Okay? No, we stopped at 16. Remember, we said from 0 to 16. Okay? So then we're going to count by 2 fours to 16 fours, starting at 0 fours. Same thing as I write. You're gonna say it as I write it on the board. So we're gonna start with 0 fours, 2 fours, 4 fours, 6 fours, 8 fours, 10 fours, 12 fours, 14 fours, 16 fours. stop right there. And so 1 is the same as how many fourths?
4 fourths.
It's 4 fourths, right?
One whole.
Whoa, 4 fourths is the same as what? 1 whole, right? Okay. Do y'all? So if we count by 2 fourths again, well, wait, let's try. I forgot to see where is there 2 holes? Do you see 2 holes represented in these fractions? Huh? Where?
8 fourths.
8 fourths, because why? Because if 4 fourths is 1 whole, so 4 fourths plus 4 fourths would be what?
8
fourths. Okay, so this would be 2 holes, right? Okay, do y'all see 3 holes?
4, 12, 14, 20,
12 fourths. Okay, all right. So we have 1 hole, 2 hole, 3 holes. So what we're going to do now is we're going to count by 2 fourths again, but this time we're going to say the fractions, but once we get to the holes, we're going to say the whole portion instead of the fraction portion, okay? So 0 fourths, 2 fourths, 1 whole, 6 fourths, 2 holes, 10 fourths, 3 holes, 3 what? 3 holes, 3 holes, 14 fourths, and 16 fourths, right? Okay, so, already did that one. Okay, so y'all go ahead and sit down. So, I'm going to go ahead and pass out your word problem we're going to work on. You don't care if I use it because ours is just the same, right? Okay. And y'all get a few minutes to work on the word problem. Remember, when you are reading your word problem, you are going to annotate and chunk the important information and be sure that what's this process or the strategy that you do when you're doing word problems?
Read, draw, write.
Read, draw, write. So you get about 5 minutes to work on this. Be sure that you write your name at the top of the paper, okay?
Yes, ma'am.
Yes. It hurts, yeah, I tried to. I don't even have a Band-Aid or anything. Miss Brandon would have a Band-Aid or anything that she could put on her splinter. Yeah, I don't think I have any. Just try to be careful with it, Lindsay. Okay, I'm gonna start the timer now. Y'all go ahead and get started, okay?
Read, draw, write means you're circling and underlining the question, circling numbers.
Because they use their journals, right?
Or do you?
Yes, and you can, yeah, and I'm gonna tell y'all, once you do that, you can start showing some of your work, you can discuss with your partner and write in words your explanation for each of your tape diagrams. Remember, the instructions tell you that you're going to give your explanation using your drawing portion is gonna be doing the tape diagrams to compare, okay? But you can discuss it with your partner group. And then you would, when you're discussing it, then you write in words, okay? just do as much as y'all can, and then we'll look at it again tomorrow. Try to get something done on it, okay? And which one is the computer on here? Is it HDMI 1 or 2? It's 1, okay. Shh. For time's sake, I just want that way for time's sake. Oh, okay, I didn't know it for time's sake if you wanted to try to go over it. Go over it. Okay, gotcha. The directions said you have to draw tape diagrams comparing.
Well, you're looking at the difference of what Allison said she ran and Jennifer said that she ran. So you would write something down, like, remember I told you what you do is you make a list. Because in order to analyze it, you have to write it down and study it, right? So I'd write something down.
The important information is like if you look here, also said that she ran this amount in the morning and this much in the afternoon, so that's how much she ran, okay? And then Jennifer said she ran this much and then this much, okay? The total, and that, I guess. Okay, so you're gonna. So start with listing your important information that you're gonna need. Like this, and this right here. So she ran a total of how much did she run? It said she ran a total of this much, right? And ran this, and that was a total of this. So you're gonna have to write that information out and draw you two table diagrams to compare, to be able to help you more easily draw comparisons of this. Okay, all right, let's talk about the word problem. Okay, so the word problem says, both Allison and Jennifer jogged on Sunday. When asked about their distances, Allison said, I ran 2 7/8 miles this morning and 3 3/8 miles this afternoon. So I ran a total of 6 miles, right? All of this information is important as well, but they said I ran a total of 6 miles, so they gave you a total amount of distance right there. And Jennifer said, that was for Allison, so then Jennifer said that she ran 3 1/10 miles and then 3 3/10 miles in the evening. So Jennifer ran a total of what? 6 4/10 miles. So how do their answers differ? You can draw 2 different tape diagrams to show the comparisons, and then we had said that we could discuss it with our partner and write it in words, our explanation for each of the tape diagrams. So let's look. So if you when you're starting out with these kind of problems, you can pick out that important information, and one of the most important things would be what? The information on the distances, right? And that'd be the most important information that you're looking for right here. So Allison, she ran what? 2 7/8 and 3 3/8. And then Jennifer ran 3 1/10 and 3 3/10. Okay? And they told have the breakdowns and how much they ran in the morning, and in the evening, they told you what their total was. So Allison, they told us was a total of how much for Allison? No, what was the total that they said for Allison?
6 miles.
6 miles, right? Okay, and then Jennifer, the total was what? What did it say for Jennifer? What was her total?
6 and 4 tenths.
6 and 4/10 miles, okay? All right, so they told us to draw 2 tape diagrams. So we can let's start with drawing the one for Allison. And you can just put A for Allison, and we can draw our tape diagrams, and we would probably do what? Divide it in, how many pieces would we divide it, do you think? To represent the amount of miles that she ran. You can divide it in what? 2 different sections, right? Cause this is the distance she ran in the morning, and this is the distance she ran in the evening, right? So she ran what? 2 7/8 in the morning, and 3 3/8 in the evening, and we said, what was the total? The total was 6, right? 6 miles, right? And so, the other one, we could draw another tape diagram for the distance that Jennifer was, walking. And same thing, we can divide it in how many pieces? And how many pieces do you think we're gonna divide it into? 2, right? Because we're talking about the distance is broken up into the morning and the evening. So 3 1/10 and 3 3/10, right? Okay. So what was the total they said that she ran? She ran what? 6 and
4
miles, right? Okay, so there's our representations of the different distances that they ran, right? So if we were using our words to discuss the comparisons, what would be an answer? Would somebody like to share what they think a good explanation would be in words for the comparison? How would you put that in words? Comparing how far Allison walked compared to how far Jennifer walked?
You could do, you could do Allison, Jennifer ran 4 and 10, 4 and 2 miles more than Allison.
Well, you can, that's one way you can say it, but one thing that I want to mention is when they are showing the representation here, they kinda estimated, because it was, if you look at 7/8 and 3/8, that is close, they estimated that number to be almost 6, so it was closer to, instead of being closer to 5 miles, it was closer to 6 miles. So they estimated, and does everybody remember what it means to estimate something? What does it mean to estimate something? Okay, yeah, well, that's a pretty close answer. So, or if you can't find the exact numbers, you can find numbers that are about the same value that are easier to work with. So, wouldn't 6, a whole number, be easier to work with than a fraction, right? So, well, an example, or another way that you could kind of put your explanation in words, it can be that Allison estimated, because we said she estimated she ran approximately, or estimated almost 6 miles. She estimated how far she ran. And she said how much? She said about, that's what, when you're estimating, and that symbol means approximately or about 6 miles. Jennifer gave what? What did she get? What did Jennifer give? And what? And then exact, right? She gave them the exact amount, right?
Can you push it up, Miss,
Oh, I'm sorry. An exact answer. Whoops. Because she did what? Because she added the 2 distances, right? Because she added. So So that's the biggest difference in the two. They basically were just wanting you to kind of give them a word explanation on how the different comparisons were made in the differences. And see, in Allison's case, they didn't add and give you an exact answer, right? They gave you a estimated answer. So that's the big difference, that Allison estimated how far she ran, and Jennifer gave an exact by adding her two sentences together. Okay, all right, y'all can just put that on top of the basket right there, all right? And I wanna show, I'm gonna pull up a PowerPoint. And I wanna we need to also kinda discuss what our objective is for our lesson before we get started and the rest of it. Okay, so looking at the board, what is our objective for today? I want us all to say our objective to get together. Okay, so let's say our objective together. It's also right up here on the focus board, but let's go ahead and state it. The learner will estimate the sums or differences of mixed numbers using benchmarks and demonstrate the estimate using words or number lines on an exit ticket with 80% accuracy. That's just that you'll be successful at the end of the lesson on your task on your exit ticket, okay? And I wanted to kind of go through some vocabulary too. Some of the vocabulary that we'll see in the lesson, or stuff that you should be familiar with, and I'm sure you're already pretty familiar with, is the term mixed number, which is a number made up of our whole number and a fraction. The equivalent fractions, which are fractions that name the same amount, same size or amount. I'm just kind of giving you a little picture, visual representation. And the sum is what? The result of adding two or more numbers, and this, in our case, it would be fractions. And then difference is the result of subtracting or taking away one number from another. Our benchmark, which is what we're gonna be working with, is the standard or the reference point by which something is measured. So one of the examples of our benchmark is what? A half, right? That's considered one of our benchmark numbers. And then fraction greater than 1 is a fraction with a numerator that is greater than the denominator, okay? And then this is just giving you a visual picture of an example of a number line, which I know y'all have seen the number lines before. It's a pictorial representation of numbers that are on a straight line, and you can use it for all kinds of different purposes. Yes, what's your question, Amir? What's your question? No, not during the lesson, no. Not till we get a break. Okay. All right, I have a video I wanted to show you. It's just about fractions on the number line. It's just about 2 or 3 minutes. Just give me 1 second so I can pull it up.
I asked what
then I'll just have to show it to y'all tomorrow. Well, I'll show it to y'all tomorrow. It's just a short video about number lines and fractions, but we can talk about that tomorrow. Okay, so let's just go ahead and go right into the lesson then. But I did want y'all to see that vocabulary, because that vocabulary is important to what's gonna be done in the lesson. And does everybody have their math, get your math journals out?
Get your math journals out and turn the blank sheet, or blank sheet paper. You don't have it on your blank sheet paper.
Does anybody need any paper? Do you not have your journal? Put your date in there. Today is what's today? 17. Okay, so we're gonna estimate the sum for the two mixed numbers, and we're gonna round each of our fractions to be able to do this. So, like what we talked about a minute ago about estimating, what does it mean to estimate again? What did y'all say?
Predict the number.
Okay, if we don't find the exact answer, we can find numbers that are about the same value, that are easier to work with. We can, find an answer that is, they said close to, but not an exact. So if we estimate, it doesn't have to be exact, okay? So that's the whole point. You can estimate to help get you closer to a number that is easier to work with, okay? So write 3 1/5 plus 4 8/9, and we're going to estimate the sum, okay? So the first step we would do what is round 3 1/5. And just think about your benchmark numbers. What do you think 3 1/5 is close to?
If you're gonna put it on a number line, where would you put 3 1/5 between what two whole numbers?
1 and 0. No, 2 and 1
Like if
Between
you had
2 and
this,
3?
like-
No, 1 and 0.
Like if you had your number line and it was 3 right here, and then you had 4 here, okay? Or no, I'm sorry,
That'd be 5.
3 and 5. And then, say 4 was right here. So 3 1/5, what would it be closer to? Which whole number would it be closer to? Or
It would go between what two whole numbers?
which one, with 3 and 4, or would it go between
So is it
4
gonna
and
go
5?
closer to 3, or is it gonna go closer to 4?
Closer to 4. 3.
Well, think, your whole is divided into how many
Oh,
parts?
it's to 3.
Look at your denominator.
5. 5.
So if that's 1, 3, so 3 and we had what, we'll go right here, 3 1/5. So if 3 1/5 is right here on the number line, which whole number would it be closer to, 3 or 4?
3.
Does everybody agree? Do we agree? Okay. So 3 1/5 is close to 3. It's a little bit more than 3. And so you would round it to, what number would I round it to?
The closest.
You're gonna round it to the whole number.
We're gonna round it to the whole number that's closest to. So it's which one? 3, right? You're gonna round it to 3, right? Okay. That's what you would round 3 1/5 to is to 3, okay? Alright, here's my spot here. Okay, so now if we're gonna round 4 8/9, think of the same thing that your benchmark numbers when you're doing like a number line, if you were doing a number line and you had your whole number as 4. So is, and look at your fraction, it's 4 8/9. So how many pieces would it be divided into? 9, okay. Okay, alright, so you have what? 4 and 1 9. And 2 9s. 4 and 3 9s. 4 and 4 9s. 5 9s. 4 and 6 9s. 4 and 7 9s. Oops, one more piece on there. Sorry about that. So I've got one of my. So if this is 4 and 8/9, which whole number is 4 and 8/9 closer to? Is it closer to 4 or is it closer to 5? It's closer, well, look at it on the number line, if it's right here, this is definitely way closer than the whole number 5 than it is 4, right? So what would you round 4 and 8/9 to? It would be rounded into, what would we round it to?
5 holes.
We'd round it into 5 holes, okay? 5, would be 5, okay? So, notice how, you have to, notice how close the mixed numbers are to the rounded number, so when you, we do figure out our estimated sum, we would have, how would we write that? If we know that we rounded 3 1/5 to what? 3, and 4 8/9 to 5, how could we write that? To get our estimated sum? It would be what? 3 plus what?
8.
No, 3 plus 5, it equals what? 8, and 8 is our what do we call it? It's our, 8 is our what? What did we say, what's the word we used at the very beginning? Starts with an E. Our estimate. You may not see, I'm sorry. It's our estimate, because what? We didn't, it's not exact, because we didn't add the exact fractions, sums of those fractions. We did what? We rounded we used estimation to round each of those fractions into a number that was easy to work with, which is a whole number, right? And then we added those estimations up to get our estimated sum, which was what? Was 8. Does that make sense? Does that make sense? Okay, so what would the actual difference be? Will the actual difference be a little more than 2 or a little less than 2? The difference between the two numbers, the difference between this number and this number.
So there you found the sum, you estimated the sum. If you were estimating the difference, you would what? What does difference mean? Subtract. So what would be the difference between the two estimates?
2.
5 minus 3 would be, because instead of adding, you would what?
Subtract.
Right? All right. Okay, so draw your line. Okay. So write down 8 9/10 plus 2 4/8. And so we're gonna first start by seeing what 8 9/10 is nearest, is rounded to the nearest 1. We're gonna find out what whole number it's gonna be rounded to, so we can draw a number line, right? And look fraction, then that tells you how many pieces are we gonna divide this into? How many pieces is it gonna be divided into? There's my two whole numbers on my number line. So if we are wanting to use a number line to see which whole number it would be rounded to, or which one it's closest to, which whole number it's closest to, how many pieces would I divide it into? Look at your fraction part. Okay. So this would be what? There's your 8 whole, 8 and 1/10, 8 and 2/10. I'll write some of them down here because it's hard. Paper. 8 and 3/10. Right. 8 and 4/10. 5/10. 8 and 6/10. 8 and 7/10. 8 and 8/10, and then 8 and 9/10 is right here on your number line. So is 8 and 9/10, if we were to estimate or round, would we round 8 and 9/10 to the whole number 8 or not? Because it's, if you look on your number line, which whole number is it closer to? It's closer to the 9, right? So the 8 and 9/10, we could round to 9, okay? All right, well, let's look at our other number, 2 and 4/8. So if we were going to do a number line for 2 and 4/8, looking at 2 and 4/8, how many pieces is that gonna be divided into?
1/2.
Well, or if we just go just by this, yeah, that's an easier, probably a quicker way, but like if we are gonna just do it according to what the fraction says, we're gonna divide it into how many pieces? Into 8 pieces, right? So let's. Okay, and so you have 2 and 1/8.
Good afternoon, boys and girls and teachers too. At this time, I need everyone to listen up. We are going to announce our PBIS winners from this past Friday. We're going to start with our flyer book design winners. So when your name is called, please report up to the front to pick up your prizes and get your pictures taken. We have from 3rd grade, our flyer book design winners are Sol Sanders, Cassidy McGuire, and Selena DeRusso. In 4th grade, our design book winners are Rodrigo Mulian, Charlie Rodriguez, and Lyric Thomas. Congratulations to all of our April design book winners. Please report to the front. And we want to give a special thanks to Ms. Moore for coordinating and incorporating this activity during her art classes to get our April flyer books. So congratulations once again to the winners, and thank you so much, Ms. Moore. Now, going on to our winners for last week. In 3rd grade, students, when your name is called, please report up front. We have Kendrick Smith, Javion Baines, Bobby Newton, Amaria Payton, Ariana Jackson, Jake Jackson, Demarian Willis, and John Foss. In 4th grade, we have Zayden Payne, Destiny Hardy, Madison Clark, Addison LaCour, Kylie Reiser, Austin Johnson, and Bentley Hardy. Congratulations to our winners for last week. Our teacher winners are Miss Page and Miss White. Congratulations, Miss Page and Miss White. Thank you, everyone, and everyone have a wonderful afternoon.
Okay, all right, so here's 2 and 4/8, or what was the other benchmark y'all said? That's also what, same as what? 2 and a what? 2 and a half, right? divide that, it'd be the same as 2 and 1/2. Okay, so if we were rounding or estimating to see if 2 4/8 was closer to the whole number 2 or 3, which one do you think it would be? Where would we round? Would we, or do we need to round 2 and 4/8? Do you think we need to round 2 and 4/8?
Yes.
Not necessarily, because 2 and 4/8 is the same as, 2 and 4/8 is the same as 2 and 1/2. It's the same as 2 and 1/2. And so you can keep 2 and 1/2, okay? Because 2 and 1/2, that's a benchmark, that's a pretty easy number to kind of work with, right? So how would we write our problem? It would be what? We would have 9 plus what? 2 and, what did we say, 2 and 1/2? We can keep that, because a half is a benchmark, that's another benchmark just like a whole number, so it's gonna be easy to work with, so we can keep the half. Okay, so what would your answer be? You would do what? You would add your whole numbers, right? So what's 9 plus 2?
11.
Is 11, right? It's 11 and what? What's left over? 1/2. So 11 and 1/2. Miss Brandon, did you want to have some work on here? Alright, so go ahead and draw another line, and we're gonna practice some estimating the differences, because that was doing the sums, and we're gonna do the differences. So write 15 fourths and 22 over sevenths. And what do y'all notice about those fractions? They have what?
Boys and girls and teachers too, please listen up for one last announcement. We want to take this opportunity to congratulate Coach Bootwan and our Weaver Elites. They were the overall champions this past weekend at the Step Show, also known as the Youth Golden Explosion. So at this time, everyone, let's give a great round of applause to Coach Bootwan and our Weaver Elites for a job well done. Congratulations, Coach.
Okay, so what do y'all notice about these two fractions? Listen.
Stop.
What do y'all notice about these two fractions? They have what? What do they have? They have different what? They have different units, right? They're not, they have different units, and so they are more than, they're what? A fraction that's what? Greater than? No, greater than, or more than 1, right? So, if we go ahead and we can go ahead and convert each of those to a mixed number. So, how would you, change 15 over 4 to a mixed number? It's gonna be what? How would you do that? Y'all have done that, right, Miss? Have y'all done that? Yeah. I know you had.
So you take it to the side and you do a number by,
Okay, all right.
And make it a, no. Yeah, no. Improper fraction. A mixed number.
So how many fours would equal, how many, fours would equal,
One whole.
One whole?
how many fours are in one whole?
3,
No, what's the denominator?
4.
4. So one whole is what? Come on, y'all.
4.
4 fours. You gotta count by 4 fours to what? To 15 fours. So you count by 4 fours. Here we go. Hold your fingers up. Hold your fingers up. Here we go. 4 fours, 8 fours, 12 fours, 16 fours is too much. You gotta go back to 12 fours. So you pull out what? 12 fours, that's how many holes? How many fingers you got? 3. 12 fours is 3 holes. So you pull out 12 fours. Okay? So you change that top number, that top number to a 4 to 12.
teachers, but could you please send one student from each classroom to pick up some flyers that have to go home today? Send them to the front office. Thank you.
So then you write it as 3 and 1 for.
Right, and so we'll do the same thing for the 22/7s, right? Do a number bond, okay, so do the same thing your county. Like how many sevens equals a whole? 7 sevens equals 1 whole, right? Okay, so if you count, like how I'm not used to doing it in this way.
So, okay, so you got 22 sevens, okay? So you write your number bond for 22 sevens. Yeah, off to the side. Okay, and so 1 whole would be what, guys? 1 whole is what? That's 7 sevens. So you gotta count by 7 sevens to 22 sevens. So hold up your fingers, here we go. Hold up your fingers, here we go. 7 sevens is 1 whole, right? 14 sevens, and then what? 21 sevens. Well, you're only taking it out of 22 sevens, so we're gonna take out 3 wholes, which would be what, 21? 21 sevens. So make another bond, Miss, and you're taking out 21 sevens. And that underneath it, write 3. So you know it's 3 holes, yeah. 3 holes.
So you would rewrite 22 sevens to what? 3 and 1 7, right? Okay, so we can round 3 sevens to the nearest 1, right? And then round. So we can do a number line.
Miss Stacy,
Yes.
I know the 3 and 1/4 is wrong. It's 3 and 3/4.
Okay, hold on. Yeah, 3. Yeah, because 15 minus 12.
Yeah, my
Yeah.
bad. I'm sorry,
Good
y'all.
catch, Savion, good catch. Yeah.
Thank you for catching that. Good job, baby. You wanna do they need to do the number lines too, Miss,
Well, yeah, you don't have to do it on every one, but, you can just tell them, look, 3 and 3/4. Is 3 gonna round closer to 3, or is it gonna stay at 3, or is it gonna round up to 4?
Not the 4.
It's a 1/4 away from another whole. You only need 1 more 1/4 to be another whole, so it's gonna be closer to what whole number? 4, okay? And then, so underneath that, you could put 4. And then 3 and 1/7, is this gonna stay at 3, or is it gonna round up to 4?
Stay at 3.
3, everybody say 3 and 1/7.
3 and 1/7.
Is it gonna be closer to 3 or closer to 4?
Close to 3.
Yeah, it's only a 1/7 away from 3 holes.
Okay, so you would do, since we're doing differences, how would you write your problem would be what, 4 minus 3, which is what? What's 4 minus 3? I know.
1.
1,
So- So 3 and 3/4 minus 3 and 1/7 is about 1. And you would do that this crazy little equal sign.
oh, the little,
Yeah.
the little estimated symbol.
So when you're finding the difference between those fractions, 3 and 3/4 minus 3 and 1/7 would be about 1.
Did you want them to tear their, did you want them to tear their?
I didn't,
Left it in the
well,
book?
you'll need it probably, huh?
I don't necessarily have to have that, let mine. don't tear it out, just leave it in your book, okay? Just leave it in your book.
It's page 109. 109. One off everybody's on. You're doing execute page 109.
Okay, so if you're going to, you have, the first problem is 2 and 9/10 plus 2 and 1/4. And we're gonna do our what? We're gonna estimate, right? So you can do a number line, right? You can get a number line. Okay, and then.
No, leave it in your book.
Did you have them do 2 different number lines on this one? Cause Okay, so if you were to estimate, like, look at your numbers right here. If you look at the fractions using your benchmarks, alright, so just using, instead of doing our number line, we can just do our rounding, our estimations by using our benchmarks that we know. So when we have 2 and 9/10, and how many pieces is that divided into? It's divided into what? 10 pieces, right? So if you have 2 and 9/10, is that gonna be closer to the whole number 2 or closer to the whole number 3, do you think?
3.
It's gonna be 3, because what? It's just 1/10 from being 3, right? So it's gonna be, we could round 2 and 9/10 stuff 3, right? Okay, and so 2 and 1/4 is divided into 4 pieces. If 2 and 1/4, is that closer to being rounded to 2 or to 3, do you think?
2.
Because, well, it, you said 3?
Baby.
Oh,
Sorry.
2 and 1/4. Do y'all agree or disagree?
Disagree.
Okay, so do y'all think it'd be what?
2.
2, right? Okay. So you just put your 2 right there, and so what was, if this is the numbers that we estimated, or we rounded, so what would our estimated sum be? 3 plus 2 equals
5.
approximately how much?
5.
5. And that's all that little squiggly symbol means is 5, okay? All right, say you have 11 and 8/9. Okay, is 11 and 8/9, is that closer to 11, or is that closer to 12?
12.
Is it 12, because if it takes 9/9 to equal 1 whole, and if it's 8/9, that's only 1/9 away, so it's closer to, what did y'all say?
12.
To 12, okay? And this one, if you look, pay attention to your symbols, this one was getting a sum, this was getting a difference, right? So we're gonna subtract, so if you have 3 and 3/8, is that gonna be closer to 3, or is that gonna be closer to 4? The whole number 4. Think about your benchmarks, because if this is 8, if 8/8 equals 1 whole, and you have 3/8, is that gonna be closer to 3, or is that gonna be closer to 4?
3.
What'd y'all say?
4. 2. 4.
No, we're not, no, is 3 and 3/8 closer to 3 or 4?
4. 3.
Well, if it, look how many pieces that takes to make 1 whole. 8 pieces, right? And if you have 3/8, is that gonna be 8 pieces, that's gonna be, how many away, that's what? How many, 8s is that till you got to a whole? That would be,
5.
yeah, so which do you think it's gonna be closer to, 3 or
3.
4?
3.
It's gonna be closer to 3. So if we're gonna do there's the numbers that we rounded, our 12 and our 3, when we were doing our estimations. So 12 minus 3 is what?
9.
Okay. So again, that's all that means, our estimated difference, because we're not dealing with adding, we're dealing with subtracting, is 9. Okay? Do y'all get how you can use those benchmarks to do that? Okay. All right, well, y'all did a good job today. I really appreciate all y'all's hard work and paying attention. So, I do need